Okay, three, two, one. Talo Falava, I'm Agate, and the presented topic, membrane capacitive deionization, desalination for coastal applications in the Pacific Islands. Here's the presentation outline. Pacific Islands such as Samoa have areas that lack clean water for drinking and irrigation. Saltwater intrusion into groundwaters as a result of sea level rise is causing an increase in salinity in water sources on coastal regions of the Pacific. Membrane capacitive deionization technology appears to be a well-suited solution to address salinity in coastal brackish waters. When combined with low energy requirements and maintenance cost, MCDI may prove to be the first choice to address the problem. Samoa is a developing Pacific island state that consists of two main islands, Upolu and Savai'i. The climate is generally hot and wet, marked by a distinct wet and dry season, and has an annual rainfall of 3,000 millimeters. Water resources are controlled by geology and consist of mostly basic volcanic rock. It is ironic, but the east side of the two main islands has impermeable soils that experience highest rainfall, and the northwest side has permeable soils that experience lowest rainfall, which causes flooding in one and droughts in the other. Samoa is fortunate to have an abundant amount of groundwater sources. However, the salt levels could, or eventually, be high for some areas. MCDI electrodes are made up of layers of activated carbon electrodes and are enclosed as stacks to deliver high salt removal capacity. How does it work? When two electrodes have opposite charge, the salt ions in the solution will migrate towards the electrodes and become adsorbed in the highly porous structure. When the electrodes reach their storage capacity, the charge is reversed and the salty waste is captured separately. At the same time, the energy can be recovered during the regeneration step to be used to drive the next cycle of the operation. This can be almost half the total energy requirement. In 2015, the UNFAO and GIZ partnered to consolidate knowledge around SPIS to address elements of UN Sustainable Development Goal number 2 on food security, in particular, the availability of water for agriculture in developing countries. The result was a substantial body of work in the form of a model framework, which is now referred to as the SPIS Toolbox. Toolbox is designed to enable people in the field of solar irrigation to provide broad, hands-on guidance to end users, policymakers, and financiers. This model framework was used to characterize the viability of water desalination technologies and recommend modifications to the toolbox. It was also provided so that it better suited the field of study. For case study 1, the Asau village in Savai'i is the capital village of the Vaisiano political district, which serves as the main business center of the west end of the island. It was found that the salinity levels in this area was improving due to enforced control measures to reduce overpumping of the boreholes. For SPIS to be suitable on a farm in Asau, this will require government, village council, and organizational support. If it were banana crops grown on this farm, the use of an MCDI water desalination system may be required to ensure quality water supply to crops for maximum crop yield. For case study 2, the Faleolo village in Upolu consists of a small community of villages and Samoa's main international airport. There are signs that salinity intrusion is present in this area. However, the salinity levels are not too high. They fluctuate throughout the year and in a range from 450 to 1,000 microsiemens per centimeter. But in due time, this fluctuation may exceed the local water drinking standards. Thus, a water desalination may need to be considered eventually for Faleolo. Patai te lava, and thank you.